What if a computer tomography had the same speed of an optical measuring machine? This is our goal, create something as quick as an optical measuring machine capable to see inside. Here I have an aluminum profile, and I put inside this element just to hold it vertical, and I put inside my machine with a rotary to acquire. That's my user interface, where I can select the measuring program, like first one, and I hit start. In the meantime I'm talking, the machine is acquiring the element. Here we can see the real speed of acquisition. So we are familiar to 20, 30 minutes of acquisition for computer tomography, but in the real, here, it is a matter of seconds. In the meantime, we already acquired something like 150, 180 degrees of the part. And at the end, to me, 210 degrees is more than enough. Here we are, all the result. So we have the distance, the other distance, and so on, all the profile around. All the value are in the same page, pretty easy for the operator to validate if the part is in tolerance or not in tolerance. And in the specific case of an aluminum profile, it's very difficult to cut properly, to stay perpendicular to the axis, to avoid bars, and measure this on an optical measuring machine. In this case, you just cut the element, you put in the machine, and we measure in the middle. In this way, it's much more easy, you save a lot of time. That's our goal. In the shop floor, with the operator, easy to use. Something more. Is this just a 2D measuring machine? Not really. I can show you how I jump from a 2D to a 3D element. That's an aluminum element, and we check the 3D shape of this aluminum element. I go here and I select my setup for the programming, and in the meantime I'm talking, you see very pretty easy setting. I hit set, I hit start, and the machine is acquiring my aluminum component. Here maybe it's not anymore 20 seconds, can be 30, but again it's not 30 minutes, and I can do just hitting a button just directly in the shop floor. So we are acquiring here the elements all around, and at the end we will see if inside this part we have porosity, blowholes, or we can also measure by cutting the element with a cross section and measure all the details inside. I can see here that the acquisition is almost completed. You see live the part rotating. Again, for this kind of application, 210 degrees are more than enough. You can go up to 360, but let's save again more time. Here you see we are now importing the data and loading inside our software. That's our software completely made by us. I jump directly here where you can see the element by itself with all the point, but here we are. I see also the element with its shape, with the mesh around, and by making the shape outside a little bit more transparent, I see all the porosity that I have inside. You see here. In the previous view, I highlighted the biggest one that is here in this picture. And when I want to see in the 3D what it is, here we are. This is very simple, easy to use directly in the shop floor. Is it something really expensive that you cannot afford? Try to check it out. It's also something pretty affordable and with a very high return of investment. Thank you for the attention. Visit us on readymetrology.com. Thank you. Bye.